In order to integrate a vector value function, you're supposed to have R, which has both x and y components. This can be very ugly and messy looking, but the value of writing the functions as vectors is I can break the integration up and integrate the components. So integrating a vector is the same thing as summing the integration of the components. You do want to keep the I, J, K notation in there. It doesn't matter whether you have a definite integral or an indefinite integral, but when you do an indefinite integral, you're going to have to remember your plus c for each component. So if I want to integrate this function right here, now I can do each step, and I will for this one. T dt in the I direction plus the integral of 3 dt in the j direction. So this is t squared over 2 plus, and I'm going to call it cx, I, plus 3t plus cj in the j direction. Okay, another way you could have written this is t squared over 2i plus 3t j plus, and then put a vector out here. I don't like doing it that way. Okay, where this is your components. I really don't recommend doing it that way. I would put them in here. The same thing works when we have a definite integral. I'm not going to redo all of these steps. When I integrate the cubed root of t, I get t to the 4/3 times 3/4. I evaluated at 0 and 1. Now I should pull the I out, but I didn't. Plus the natural log of t plus 1. J, for consistency, I'm going to do it the same way here. Minus e to the minus t, k, evaluated at 0 and 1. And when I do this evaluation, I get 3/4 I plus the natural log of t minus 0, j, plus 1 minus 1 over e, k. Now, what happens when we have initial conditions? See, these are my plus c's. These are my constants. So when I find r, okay, r, it's not, it's just r, it's a vector. I got carried away. Okay, so I'm going to integrate cosine of 2t dt I, and then minus 2 times the integral of sine t dt j plus the integral of dt over 1 plus t squared k. Now, when I do this, I get 1/2 sine 2t plus c1, and this is in the I direction. I know that looks like a j, it really is an I. All right, now I'm integrating sine, so I'm going to get rid of that negative sign there. That's going to be plus 2 cosine plus c2, and this is in the j direction. And then this is arctan. In the k direction. So now I want to use my initial condition. And I'm just going to equate these. So when t is 0, let's see, when t is 0, the x is 3. So 3 is equal to 1/2 sine of 0. C is, so c1 is equal to 3. When t is 0 here, I have negative 2 is 2 cosine of 0 plus c2 All right. So C2 is 4. Actually, it's -4. And when I plug in inverse tangent of 0 here, I get 1 is equal to the inverse tangent of 0, which is 0, plus C3. All right, so my answer is R of t is equal to 1/2 sine 2t plus 3 I plus 2 cosine t minus 4 j plus inverse tangent k. So what started out as an ugly problem actually simplified quite easily.